Hi guys, and welcome back to another episode of the Mini Machine Job. I'm Dave. Like I said before, I'm still missing a ton of videos. I went through everything and they're gone, which bummed me out, but this is just a quick little video to show a couple of things here. One is, I said I'd rearranged and I managed to figure out a spot for the collets. Excited about that, just exchanging some stuff between the drawers. So this is real nice and easy now. It'll stay clean and I can easily get to them. So there's that. And I will show a section of video. I got another toy. I saw it on Amazon for $30. It's import, of course, but it's pretty nice. So I'll show you messing around with it on the surface plate. And the rest of the little quick stuff that I'll show is, oh yeah, I had to make... that was a kick. I had to make the back piece to hold it. I think you guys can see it. And I was making it out of steel. And what did I do? I turned this part first, then turned it around and was trying to do the threads, but it kept spinning here and I couldn't hold it. It was messing up the surface. So then I tried to do it the other way around and that didn't work either. And I said, okay, forget steel. Just make it out of aluminum. So it's done and it works nicely. It gets marked up by the Allens, the set screws, when I use it, so, but good enough. And I'll show just the last stages of completing the power feed for the Grizzly mill. Alright. Okay, new shop toy. $30, Amazon, 0 to 2 inch dial indicator. For $30 I had to get it in case there was something. Oh, it's crooked here in this axis. It didn't come with it's going to be tighter. It didn't come with the holding part back here, the nut and the pin, so I had to make one here earlier. But let's see, I can check the flatness. I'm probably going to get in the way of the camera, but check the flatness of this guy. Alright, raise it up. Wait. Come on, surface, right? Well, it's staying put. It's supposed to be precision, and it is. Here. What else can we check? I guess I can check this surface. Why not? Wow, look at that. No. I think my stand isn't that stable here, that I'm getting a little bit of movement as they go back and forth, but probably have to eventually get a better holder. I think the holder's in the camera. Yeah, you guys can see it. Tilt it down. It's just sitting on a vise. That's all I had for support to get it over on the table. I didn't want to stick the vise on the granite block, but alright, so I guess I can show you guys the back of it. You can see the part that I made. Sticky old Allen in here. Loose nut. And there's the back. Simple little nut and knurling. 1/4 inch pin. And done. Oh, yeah, I was always curious too. Why did they make the plastic a dome? You want to set it down like that to protect the thing, but you're sitting on the dome. Should have been flat. I checked my other dial indicators and they're flat. That's like, okay, rock. Couple of things I just want to say first. I was watching a YouTube video on a mini pallet, which everybody's seen mine. Come on out, or right there. The guy's drilling the mini pallet, making his, and every other hole is threaded, and in between those it's not threaded. And then he shows putting some of the pins in the non-threaded holes, and then he just puts a block of metal puts it on against the pins, and that's the end of the video. Like, how are you clamping it down? What? Useless kind of video. I don't know what the guy's doing, but no way to clamp it down. I don't know what the purpose of the pins are for, but so I correct myself in saying, you know, the guy didn't show how he clamped things in the mini pallet. So I did find the video again, and I left a comment asking him a question. It's like, okay, you show the pins, but you don't show how you clamp the part. And he said that he's just using the pins only to get the part aligned up, you know, straight, parallel, whatever. So I was thinking, you know, your pins had better be really accurate and no sloppiness in the holes if you're going to use it to get it real tight. And then I started thinking, you know, wait a minute here. In my palette, I'm using basically to make rough cuts. You just hang something off the edge and just bevel it 45, 60 degrees. Nothing really critical. But I started thinking as I made this, what if, how accurate are the edges, the sides to this thing? Because I'm using the side with the little plate on it that I've shown to square up the part. And so I started thinking, well, let me put the dial indicator on it and see how straight the edges are. Now this is the really sensitive test indicator. From 0 to 1 is 1/1000th of an inch. The other neat thing is I get to use come on, I'm stuck for words today. I get to use the power feed to check this out. So let me just fire it up. I'm close to 1. Let me put it on the 1 if I can. Which way do I gotta go? Wrong way. Oh, I'll put it on the 0 then. Oh, close. Tap it. Yeah, close enough. So there it is. Let me start the power feed. Let's see what it does. It's hanging kind of in there, I think. I'm at a bad angle here. Yep, now it's moved about 2/10 or 1/10 off. It's a bump. Yeah, it's pretty good. Let me move it a little faster. And now we're getting up there a bit. Let me re-zero it and then go back the other direction. Put it on the 1 so I can see it. There, yes, it's hard to move it that slight. Alright, tap everything. Yep, looks like hopefully it's solid. I want to go that way. Yep. Move it a little faster. Alright. Yep, he just went off. No, yeah, it's bouncing around. Rough surface, I guess. 2/10 now. Looks like it's kind of consistent. Yeah. 3/10. That's pretty good. Well, it's pretty good over that distance to be. Yeah, it's going to be coming up on 1/1000. It's 6/10 right now off. But wow, that is pretty good. I wish I could get on the back surface, but I don't have the travel. Oh, I could turn it around. Duh. Because that's the surface that counts. Let me flip this camera over so I can see. Yeah, I'll flip it around. You can see the plate that I'm using here to square things up. So it's the actual, let me fall down. It's the actual plate that I want to check, because that's what I'm squaring up to. Put it in nice and tight. Come up, come over a bit. Power feed, go that way. I'll have this power feed. I'll show you something else here in a minute, one of the finishes. Alright, come down. That's good enough. Is that clean? I think it's clean. Yeah, probably. Alright, so can I travel the length of this? No. I've still got to rearrange a little bit here. If I go too far left, it's going to hit the stepper motor on the lathe. Come on. There you go. Ooh, I'll have to go up to 1 so I can see it again. There we go. Is it solid? Yeah, it looks like it's pretty solid. Okay, so I want to go that way. See what it is. Did half a tenth. Yep, just bumped up over a tenth. And it's back down to 2/10, bumping up. I really have a rough surface. I wonder, how did I finish that off anyway? Take a look at the finish on it. So I don't think I ran this through the fly cutter. Yeah, no, this is just sanded rough. So 2/10, 3/10, it went, what did it do? It went at least half of the plate and it was off only a little bit. So for what I'm doing, that's not bad. While I've got the camera zoomed in, I did put the fly cutter in there, excuse me, and ran it on a surface. I think the camera can see that surface. Where is it? Oh, no, you can't see that surface. I gotta come up there. Hang on, I'm trying to look in the camera to see what. But that's basically a mirror. Can't tell. Yeah, you can see the reflection in there. So my eliminating the human hand, because I'm cranking on the handle and I'm jerking it all around, I know, the movement. But now with the power feed, I'm getting another level of improvement. The finishes are a little bit better, because again, I'm not jerking things around. It's pretty nice. So I love the power feed. Alright. Alright, here's all the pieces. The plate is on the end. Right now it's just mounted on the end of the table. The motor is going to be screwed on the table. This guy will get cut off, hole drilled in it. It'll be part of the motor here. And a set screw. Just put it in place. This guy will be permanently on here. I'm probably going to either make another one that's tighter or put some silicone or something in there. This guy is with the screw through it, goes in the slot. So this can move on the end of the lead screw. I have to make another one of these bigger and put some pins in here that will go into the groove. There will be a rod, I'll just use this for now, there'll be a rod screwed in here like that. This will get screwed into the plate with a hole, and the rod will go through here into that, and it'll just push, pull, and engage it. It'll go while this is turning. Whoops. Yeah, I need to definitely fix that in place. This will be turning all the time. So when I pull it, it'll just engage and start doing it. I can push on the rod and disengage the thing. So that's the concept. I just have a little bit more to go. And for now, I'll probably use that motor controller I showed in the last video. Did you guys watch this? I'm making the faceplate for the power feed, cutting out the square that the little pulse width modulator motor driver goes in. Free. I don't want that thing to grab it. Come on, break off. Hey! There we go. Alright. Clean it up, okay? didn't go too far. Alright, well, I'll just finish cleaning it up. Well, that's the control panel so far. Still going to make another label. These are off a little bit. And I want to put the flathead screws underneath the label, 3 spots, and this will mount on the face. Because I was thinking if I put it this way on the top, all the chips and garbage are going to fall all over it and make a mess. So I'll put it on the face, and I'll have to do something to protect the electronics in the back. This guy, the nuts over here, so I got to cut this. Actually, I'll desolder it, put it in there, screw it down, and then resolder and heat shrink it. Shorten the wires a bunch too. So I may actually shorten the wires on the pot. So I've got my speed on, off, and left and right. And it's pretty good. I'm not sure if I have to make another piece up here for it and screw it here and screw it on top for support. Once I get it in there, I can kind of feel it and see how well these things are holding this panel, because the other piece that it's bolting into is a 1/4 inch thick. So it's coming along, boy. What a lot of work. Oh, and this drilled real slow. This is bigger than a 1/2 inch. It was 0.6 something to mount this guy. So the whole mill was shaking like crazy. This was put on the mini pallet and hung off the edge so that I could find this edge, come into the center, and then drill all the holes where I needed. So hopefully next view everything should be running, I think. Figure before I put the faceplate on, there's the motor. Amazon, I will be posting schematics, diagrams, so if anybody wants to drill the holes and mount this motor and a link to it, the motor is on Amazon. It was $30. And I don't know if I can see really underneath. Yeah, you can. So there it is. And that's engaged, disengaged. Can't get it out. Ow, I cut myself up. Oh, I just cut myself bad. Okay, you saw me try to disconnect that coupling. That dovetail under there, that thing is sharp, boy. It cut really deep. So if you guys decide to build one of these things, be careful around that sharp dovetail edge. Well, there be the power feed. Oh, almost complete. Everything's done. I just haven't put the engage, disengage. This would screw in back behind here, and then the rod would go in and it'd build that little C thing that I've shown before that would grab it. But in playing around with it, and I've done some fly cutting like I said, I'm either using the power feed all the time or I'm just manual. So for now I'm just going to reach under and disengage it. But there's the guy, and again this is percentage of pulse width. You know, if 100% would mean you're full on voltage. 50% means you've got a dip in the wave and then a dip, and it's 50% on, 50% off. So, kind of a nice label, printed on the laser printer. I'm going to leave the plastic on there for now, just to protect it. I know eventually it'll come off. And then I've got that going that way with the table, nothing, and then left with the table, and I've got the speed control. Take the table that way. You can see the whole thing moves. I'll take different angles so everybody can kind of see it. The gear motor's hanging down here. I was lucky. It clears the piece of wood by like a 1/10 of an inch or 50 thousandths, something like that. But I got to do something on this side here. So let me bring the camera over. I guess I can just detach it and show some of the stuff here. Alright, there it is. So if I go up above, ooh, zoom out. There's the motor. And again, that was an Amazon. That was a $30 motor. It was expensive, but a worm gear, all the stress is on the worm itself and not on the motor. So it makes it a lot more powerful, I'm sure you can imagine. And all the wiring and stuff. And then underneath here, I think you can see that. there's the socket, and I need to remake this part on the motor because the socket flops around too much and it's causing some strange movements. So for now, and I do have CAD drawings of all these different pieces because the dimensions are really critical and crazy. So if anybody wants the drawings or anything like that, just let me know. And you just turn it on, and there she goes. It's really cool. And then, like I said, I can just take it here with my hand. Let's see if I can do it. I can't do it. Well, yeah, I need two hands to do it because I got to move the handle to get it. But I've got a power feed. Yay! Alright, show you guys a little bit of behind the scenes. Right now, I've already uploaded the newest video, 49. It's being processed right here. So, and, what's in the email? Oh, new subscriber. Victor Mendoza subscribed. How many subscribers do I have now? Bring this guy back up. Videos. Here's the videos. Community. Subscribers. 440. A lot of them. Nice. Very happy with that. But just wanted to show you guys how the video editing is done. Here's the videos I just pulled in off the camera. And I've got one folder here which says intro and my projects here. And this is Premiere Pro CS4. And all I do, I've already got the intro, stays down here on the timeline. Just go to the end of it, right click, import, desktop. Where are you? Videos. Highlight them all and open. Now the reason this is pretty fast is because this isn't running a regular hard disk. There is a solid state hard disk in this thing. What's what? Probably the last. Nope. Where's my intro? Nope. Where'd the intro go? Not that, not that, not that. I can see up in the top left with this. Oh, this must be it, right? Yeah, probably. There we go. Yep, that's it. And I freeze it right there, and I say from that point on, I want that to be in the video.
Hey guys, and welcome back to another.
And then I can go all the way down to the end.
And I'll show just the last stages of completing the power feed for the Grizzly mill. Alright.
A little bit more. There it is. Say that's the right piece. And you just come down here and say drop it in. And it's in there. So I can cut, edit, do anything I want with all the different pieces. And at the end, where's the ending? There's the ending. I just drop that piece in there at the end and then do all the fades and produce the video. So not too bad. Like I said, this guy is pretty fast because of the solid state disk. I mean, pretty much so. Anything I click on is like boom, immediate. So get a solid state disk. They've come down quite a bit. And it's pretty easy to install. This is running, what are we running? This is Windows 7, but it's not that great, not that much. Yeah, it's an Intel Core i7, 2.3 gigahertz, 64-bit operating system. Not bad. Not bad at all. Okay.